Hey guys, welcome back to AlgoYogi, and we are doing the tree series right now. We have started solving the medium problems, and our next medium problem is lowest common ancestor of a binary search tree. Let's go over the problem description. That is, given a binary search tree, find the lowest common ancestor node of two given nodes in a BST. I'm sure you guys already know what a lowest common ancestor is. That is, given two nodes of a tree, we need to find their common ancestor. They need to be the descendant, they're both the descendant of this common ancestor, but they can have multiple common ancestors. However, we just need to find the closest one. Like let's try to find their parents. We keep going up till the root, but wherever we come across the node where both the nodes P and Q are descendants of that particular node, then we just return that node. Okay, so let me change the view here and we can go over a few examples. In the first example here, it's really simple. We are given P as 2 and Q as 8, and if we look here, P is 2 and Q is 8, their common ancestor is the root itself, so its answer is 6. Now, what if we had some different values? Let's say instead of 8, I think not 8. I think let's change both values. Let's say if we had 0, P as 0 and Q as 3, which would be P here and Q here, what do you think their lowest common ancestor would be? This time it's not going to be 6. No, it's going to be 2. This is the LCA of P as 0 and Q as 3. And the reason is, if you travel up till the root from here, this is the point where you both basically you had a common parent, where you basically combined in the process of going up to your up to the root. Okay, so this is one example. What could be another example? What if we had as P as 3 and Q as 5? Then our common ancestor would be 4. What if we had the value Q as 4? Then also we would have our common parent as 4. Okay, since P and Q can be the parent of each other or the child of each other. Okay, so now how are we going to approach this problem? How are we actually going to approach this problem? This is actually quite simple. It's just, since it's a binary search tree, we have to know when we are going to do the pruning of left or right based on my roots value and my P and Q node. So here's the thing. Right now, let me change the color here, it's not suiting right. So in our first example, when I started processing my binary search tree, then I see, okay, my root value is 6, which is basically between 2 and 8. That means what? That means my left basically I am the node where I am dividing those two values. One I'm sending to this to the left, and the other one I'm sending to the right. Why? Because see look here. If this value, my root value, is basically between P and Q, then I have to return that node because this is the common ancestor, and the reason is, if this is less than P is less than 6, then it's going to be in the left subtree, and if q is greater than my root value, then it's going to be in the right subtree, right? It's not, you're not gonna find it because all these nodes are going to have value which is lesser than 6, which is the root node. So you have to understand that part, that if the pruning will only happen when my root node is either lesser than both of them, both p and q. If let's say my root was something like 1 or something, and then I was looking for a common ancestor, then don't you think if this was 1, let's say I'm just calling it 1, and just for the sake of this understanding the situation, that I will not find common ancestor in the left subtree if this was 1, if this was 1, if 6 was 1. Okay, I'm not going to change it, like, okay, just imagine it. So don't you think we will find our common ancestor on this side, on the right side? So that's what I'm saying. The pruning will happen if only if our p and q either both are greater than our root. Then that means we will have to go to the right side. If they're both lesser than 6, then we have to go to the left side to find the common ancestor. Otherwise we will just return the root. So let's implement the solution. I think it's really simple. We can try doing the iterative and recursive approach both. So let me change the view here, and let's write the solution. And I'll just have a helper function, makes the code a little cleaner. So let's just call it helper, okay, which is going to take the root. We will have access to p and q. So if root is none, or p is none, or q is none, that means we return none. And it's because in our constraints, sorry, not restrictions, constraints, they have given that there will always be answer. So this will not get processed ever, okay? If my root dot value is greater than p dot value, and my root dot value is greater than my p dot value. I should have written it the other way, p and q, but it doesn't matter, okay? Then we return, what do we return? We're gonna call helper function, okay? We're gonna call helper function on the, if my root is basically greater than both of them, then I'm calling the left side. Elif, if my this condition is basically if my root is lesser than both values, that means we have to go to the right subtree. So this is where you have to make the choice of pruning left or right, and that you are doing by checking if your root is basically either greater than p and q both or lesser than p and q both. That's where you either go to the right side or go to the right side or go to the left side. So this is where we go to the right side, and otherwise else we just return root, okay? Otherwise we just return root. Now let's try to call this helper function on the root, okay? Let me zoom out and run the solution. and yes, passes the test. Let's try to submit it. Okay, cool. Let's talk about the time complexity, which is in trees problem. It's always time complexity big of n is the number of nodes. Oh, sorry, no. This is BST. That's pruning, guys. Sorry, sorry. That will be log of n, because we're basically either pruning, either we are returning, or we are just pruning half of the subtree, basically. And then space complexity would be big of h, which is height, which could also be big of log n also in worst case. Let's just call it h for now. I don't care. H could be equal to this. Okay, so good. But anyway, I also said like we can write the iterative version as well. Really simple, that one also. We just need to process convert these conditions into using the stack. And let's just write it really simple. So we're gonna call car as our root, and then we're gonna have while car current. That's what I'm talking about. While current. Okay, sorry, I should just call it root, not inside the queue. Like I'm not making a queue right now. So if cur dot val is greater than q dot val and cur dot val is greater than p dot val, then my cur is cur dot. If this is greater than both of them, then basically we go to left, and let's process the right side, and that will happen if my node value is lesser than both of them. That means I have to basically go to the right side to find the common ancestor. Okay, otherwise else return root or return cur. This is it. Okay, and because we are going to have answer always, so then I think this should work. We don't have to have a return statement like here, since it said this will have, there will always be p and q not equal, and node values are unique, and they will exist. So if they are existing, that means we will have an answer, at least two nodes, either parent-child relationship or they will have a common ancestor. So let's try to run this solution as well. Okay, and submit. This will also going to have a big of log n. Okay, I think we have some problem here, and that would be failing this, expected this, and I think the problem could be q dot val, p dot val. Is it about it's processing both time and I didn't have elif? Yes. Okay, cool. So you guys know we don't want to process the other side if we have already decided to go on to the other side. Okay, let's go, because otherwise it will change the current pointer, right? We are processing left, left, right, and then suddenly it just started processing the other side. I hope, like, when you imagine this, you're getting what was the error there. Okay, so let's go back to AlgoYogi and mark this problem solved, and see you in the next problem. Bye bye. Please like, share. will give me some support, some motivation to keep making these videos. I'm just beginning, guys, so I will appreciate any support here. Will keep me going.